Hi there, my name is Jeff, and today we're going to be talking all about 3D printing. So, as we work through our session today, we have two goals. One, I'm hoping by the end you'll be able to tell me some different examples of how 3D printing is used in different professions. And you'll also be able to use some software to make your own design using TinkerCAD. So, to get started, just to get you to think about some things before we go too far, just wanted you to think about what you already know about 3D printing and what are some examples of 3D printing in the real world that you already know about. So, we want to just pause and think about that for a second before we start moving along here. So this is an example of a 3D printer working. If you've never seen one before, they work by using a plastic filament that they heat up really hot, and it puts it down in specific locations, starting at the very bottom in a layer, and then it goes up a little tiny bit higher, and it draws another picture, and it goes up a little bit taller and draws another picture, until by the end of something like this, um, it starts to really turn into something. So this is an example that's a pretty large print. This would have been many, many hours on the printer. This is in time lapse. If I just kind of jump ahead, we can start to see how this kind of comes together over time. And by the end, this makes a pretty large model of the Eiffel Tower. So I'm just hoping to share some examples of 3D printing in the real world that are affecting people. So the first one would be one that's a little more consumer based. This is a custom sneaker. So there are stores that you can go into, and they can take a three-dimensional image of your foot, and they can 3D print you a sneaker that will fit you and nobody else. So it would be like really comfortable for you, but if somebody had to borrow your sneakers, they would probably find them pretty uncomfortable. This one's one of my favorites. This is 3D bioprinting. So instead of using plastic, like in the Eiffel Tower example, this is using tissue. So what that means is they can take a sample from a person and create more tissue with it and use it to create a body part or 3D print a part for their body that they can use inside. So for example, as it is now, if somebody needs a heart transplant or like a valve for their heart, for example, they would have to wait for an organ donor. So they would need somebody else's real heart that matches the same blood type. They're about the same size. There's all these things that need to line up for them to be able to do a transplant. But with this bioprinting, they would be able to take like an image of the part that they need and use tissue that from that actual person to create the part that their body needs. Another example might be, say, for example, I was in a car accident and I lost a part of the cartilage in my ear. They could use this technology to 3D print me a replica of what it needs to look like for that cartilage piece, and then insert it and do out through surgery fix my ear and make it look symmetrical again. So these are just two quick examples of things that bioprinting is working towards. So this is a pretty large scale printer. This is printing with concrete, and they're building homes. So the beautiful thing about this is that they can build a home this size, like we're seeing in the video, for about only $4,000, and they can do it in a day. So if you know anything about the housing market here in Nova Scotia, people spend hundreds of thousands of dollars to buy a home or to build a home. So to be able to do it so cheaply is pretty incredible, especially when in a place like in this video, in the country of El Salvador, people are living in extreme poverty in some places. So this is an example of the neighborhood where the people might be living beforehand. So it's the kind of home where if there's a storm, you don't know if you're going to have walls at the end of a storm. So they're giving these people security for their families. They're giving them that feeling of safety and something that they can rely on for their home. So it's a pretty big deal to be able to provide this kind of thing for people, and it's only available because of 3D printing. I think 3D printing is a pretty common thought when people think about prosthetics. I can picture Terry Fox, 40 years ago with his prosthetic leg. Now, that would not have been 3D printed. Those kinds of prosthetics are still available, but they can be very expensive. So instead of prosthetics costing tens of thousands of dollars, with 3D printing technology, we can do it for hundreds. So that's a pretty big jump from hundreds to tens of thousands. So that means that people can get the tools that they need so that they can live, healthy and normal lives. Similar idea is assistive devices. So these are things that can be helpful for people that have mobility issues or physical disabilities with things like, could even be something like arthritis. So if you had a really severe arthritis, it might be really difficult for you to do fine motor movements, like things like being able to hold a key firmly enough to turn it or to do up buttons on a shirt can be difficult. So they have these assistive devices to help and make it easier for people. But the problem, again, just like the prosthetics, is they can be really expensive. But with 3D printer technology, people can 3D print these assistive devices, and they cost literally pennies instead of tens and 20, $30 for a single item. So we're able to give people the tools that they need for a fraction of the cost. And we can also help animals. So, this bird uses its long beak to pick up and to be able to break food apart. So, when he was injured and lost that top section of his beak, he wasn't able to do that anymore. So, they were able to design and attach this new beak using 3D printer technology so that this bird can live a normal, healthy life again. He's able to use that the beak to break his food. So this dog was able to get a prosthetic limb as well using a 3D printer, and this tortoise had an injured shell, and they were able to 3D print them a new one. And this last one's just for fun, but this is the Pancake Bot. So for about $300, you can be 3D printing your own breakfast. So it puts it down in a specific order. So the longer the batter is on the pan, the darker it is. So when they go to flip this over, we can see the grayscale effect. So where some areas are darker than others, and then you can eat an astronaut for breakfast. All right. So usually in a session, this is where I would have people kind of turn to each other and just talk about some of those different examples of things that are interesting with 3D printers. But you can just kind of think about that to yourself. Which one of those kind of stood out as being interesting to you? Okay. So now I'm going to move into using TinkerCAD so we can do our own designs. All right, so I just got signed into TinkerCAD. If this was your first time ever signing in, it probably took you to a tutorial page where it's already has some shapes and things that you can work with. For the purpose of what we're doing today, I'm going to get you to click on the TinkerCAD logo in the top left corner, and that will take you to the page that I'm on right now. So this is where you can see all of your past designs, but you can also create a new design. And it just takes a second to load, and then we're into our work plane where we get to make something today. So the first thing I'll point out is the file name it gives. So in Google Slides or Docs, we know that it just calls your file an untitled document. In Tinkercad, it gives it a like a nonsense name. So mine is a fantastic Turing Jadrub. So if I click on that, I can change it to something that makes more sense. I usually suggest that people put their name and also what they're making in that box. This makes it easier for you, your teacher, and anybody that's working the 3D printer because they know who it belongs to and they know what it's going to be when it's finished. So definitely get in the habit of putting in a name right away. So to navigate your work plane, it's really important that you get used to changing the angle that you're looking at things. Sometimes with 3D objects, when we look at it from one side, it will look really good, but when you spin it and look at it from another angle, it's not at all what you expected. So if you click on this cube and hold it down and then just move your mouse pointer, we can spin this work plane around and look at it from any angle. If you are on a mouse, you can use the right mouse button to do the same thing. So if I hold down the right mouse button, I can tip the work plane around. If you're on a laptop, a great trick is to use two fingers and just slide them back and forth on your trackpad. It lets you do the zoom in and out. And if you're using a mouse, you can use that scroll wheel in the middle to do that same thing, zoom in and out with the scroll wheel. Sometimes in TinkerCAD, you kind of get lost in what you're looking at, like you're not sure entirely where you are or where your design went. So that's where this home button here on the left comes in handy. If you click on the home button, it just zooms you back out so you can see everything from a distance again. It's pretty handy. And for us today, and in most things that I ever use in TinkerCAD are in the basic shapes. If you do that drop down menu, there's a ton of things in here you can explore, but we're just going to stick to basic shapes for today. So, um, like I named my file a keychain, but you can think of this like a backpack tag. It could also be a dog's tag or like a label for a suitcase or something. So we're going to just make something that's kind of flat looking, but it also has some text and some other features as well. So to get started, I need you to pick I'm just going to move this up here. I need you to pick a shape that is flat on the top and on the bottom. So some that would work really well would be the box or the cylinder, or if you go down a bit lower, the polygon is great. So would the heart or the star or the tube would all be great for today. And then you can just drag that shape onto the work plane. So I picked the polygon. It's not really looking very much like a keychain at this point. So to get started, I'm just going to lighten it up a little bit. So if you click on where it says solid and there's the color blue, you can change it to anything that you like. Keep in mind, though, that the colors are for display on the computer only. When you go to a 3D printer, the only color it can print is the color of the plastic that is being put into it. Um, so multicolored designs are awesome on your screen, but unless you have a multiple color printer, which most people do not these days, you'll be printing in just one color. So now I need to change the size of this shape so that it looks more like something that I could use as a keychain. So using these white squares that are around my shape, I can drag that out to change the shape of it. You'll notice as well that as I pull on those white squares, the numbers change that are beside it. So these numbers are the length and the width of the item that I'm making. So if I'm looking at those are in millimeters. So if I remind you of a ruler, if I can get that in close enough, millimeters are those teeny tiniest little specks on a centimeter ruler. So for every 1 centimeter, there's 10 millimeters in there. So that can really help me when I'm trying to decide how big this should be. So if I'm, looking at my ruler and trying to decide how big I want it to be, if it's I think for me, 6 or 7 centimeters is going to be plenty. So that means in millimeters, that's about 60 or 70 millimeters. So I can click on one of those squares and I can even just put it right in the box. I can just click and type how big I want it to be. So I'm going to make mine a 60 by 60 shape. Sometimes with a keychain, they're more that longer shape. So if you would rather design it so that it's, more of a long shape, that could work out really good too. And the last adjustment I'm going to make for this, if I am taking that and looking at it from another angle, it actually looks like it's really thick. So if I go and I click on this center white square, I can see that it's 20 millimeters. So that's 2 centimeters thick. So that's pretty big for a keychain. So I'm going to pull that white square down and flatten it so that it's only 2 or 3 millimeters thick. And that will be a better keychain for what I'm trying to create. We're not going to use this tool today, but I just want to show it so that if you use it by mistake, you know how to fix it. There's this black triangle that shows up above my work. If you use the black triangle, it actually makes the shape float in space there, which is really confusing for a 3D printer. 3D printers don't like it when things are floating. So if you do that by mistake, you can see that it's created this shadow. I know, oh man, I didn't mean to do that. You can just hit the undo button and it will just snap back down to the work plane. You can also use that triangle to drag it back down. If I kind of zoom in, I can show you. I'm trying to make this dotted line up with that blue square on the bottom. So once those kind of snap together, I know that it's flat on the work plane again. All right, so I've got my base shape ready for my keychain. Now I'm going to add some text. So if I'm at the top, it's about 5 rows down. There's this red one that says text. I can drag that in and I can change what the text says in this box here. So I clicked in the box, I can just backspace those letters and I can type it in. It gets way too big. But that's okay because just like with the shapes, I can use those white squares to squish the letters so that they fit inside what I'm making here. And I also have the option to change the font on the side. That font has a little bit more narrow letters, so that works out better for what I'm doing, I think. And like I said earlier, when I look at it from one angle, it looks pretty good. But when I just give it a twist and I look at it from another angle, I can see that those letters are standing up pretty tall. So I am going to lower those letters down so they're only sticking up a little bit past the base shape that I used. So I'm going to make mine a little bit taller. There. And you also have the option to add a second row of text, like if I wanted to add something smaller underneath. I can just shrink that down and it could be like in a second row of text. So adding multiple lines of text is fine for this too. All right, so if I'm thinking about this as being a keychain, it's going to be pretty important that there's a hole in it so that I have something to attach the keyring to. So at the very top of my basic shapes, there are these two grayed out shapes, and those are both already set to be holes. But anything in TinkerCAD can be set to be a solid or a hole. So that's even true for those letters that we used. I can take that text item and I can change it from a solid to a hole. Sometimes that might make sense for your design. For me, I'm going to stick with the solid, but just to let you know that that is an option. So I'm going to take that cylinder hole and drag it onto my design. And that came in pretty big. So as it is right now, that would be a pretty massive hole for this keychain. So I'm going to shrink that down. Again, I'm just going to use the numbers. So change it from 20 to maybe 5. So now I've got this much smaller hole that I can position where I'd like it. Sometimes with the keyring, people put the hole on the side. So just think about the design and function of your keychain and where you think it makes the most sense. I'm actually kind of noticing that my keychain looks pretty long, like tall, I mean. So I'm just going to shrink my shape a little bit now too. You're always able to make lots of changes. All right, so now I've got this base shape, some text. I put a hole in my keychain. The last tool that I want to show you from the basic shapes is the Scribble tool. So if you find that, it's about the third row down and it just says Scribble, you can drag it on. And when you do that, it brings you into this Scribble Editor. So this lets you do a two-dimensional drawing on your screen. Really nice if you have a touch screen. So you can do whatever two-dimensional drawing you like. There's an eraser tool as well if it helps to be able to erase things. And when you hit done, it takes your two-dimensional picture and turns it into a 3D shape. And then just like before, we can size it, flatten it down, and my hand-drawn picture can become a part of my design. Okay, so that's all the basic shape tools I wanted to show you today. But there's a couple other little things that come in handy when you're doing design. So, just like if you're in Google Slides or drawings, you can use your mouse to draw a box around a couple different items, just like this, so that it selects them all. So now I'm not just able to change one shape, whatever I change changes in all of them. So if I change one thing, it changes everything. So this becomes handy, one, for resizing, but two, I can align things really precisely. Like if I'm looking at my design, my hole is not at all in the middle anymore. So if I have all these things selected, and then I go up to this top right button that says Align, it gives me these circles that I can click on. And if I just hover over them, it shows me what it would look like if I clicked on it. So if I want everything to be kind of aligned to the middle of my design, if I click on this one, it just gives things a little shift so that everything lines up nicely with that middle point. And you might not want everything to be aligned the same way. So now I'm just going to select the text and the outside shape. And if I click on the align tool again, now I can align it with the center. And now that that's in the center, I can see that my smiley face probably should shrink a little bit. And then I can align it again. And that's starting to look a little bit more intentional or lined up. Something else to mention about this hole, if you think that it looks kind of weird that this hole stands up so tall, it does kind of look funny, but you have the option to shrink that down. But it wasn't going to hurt anything to be tall like that. It's going to be fine just because it was a hole. So one thing to make sure of though, when you are using a hole and you want it to go all the way through, if you spin it and look at it from the bottom, you should be able to see the circle there. That's how you know the hole is going all the way through. Sometimes people with their design, they will kind of make sure that it's sticking totally through, which is fine too. You can see now I can see that hole is completely sticking through my shape, and that will also turn out great. So for this first intro, this is everything I wanted to show you. Um, so if I want to really see what it's going to look like on the printer, I can again select everything and I can use this grouping tool, and it takes all my shapes and turns them into one shape together. And that lets me see how this would turn out by the end. So I think my smiley face sticks up a little bit too high, but well, otherwise it's pretty good. So if you signed into TinkerCAD using a class code, your teacher will automatically have access to this. But if that's not what you did, you'll just hit the export button. I always suggest making sure that you have this everything in the design is checked. And then you can download it for 3D printing as an STL file. So when you click that, it will download it onto your computer, and then you can email that to somebody, or you can send it to a program like Cura that you can use to get the file ready for 3D printing. And that's it. So our keychain is ready and ready for the printer. Um, so thank you very much for following along with us today. If you have any questions, you can talk to your teacher or ask them to ask me directly if you have anything that I can help you with. So I hope that you enjoyed this and have a great day. Thanks so much.